Okay, good morning. My name is Goris Yang. So I will be presenting about project 2 for PhD. So for this project, we will be doing basically statistical analysis on the data set that we have. So for the data set that we will be using is the data set we got from the survey from the project 1, which is a survey on factors that affect student choice of game genre they play. So you use that data set. So in this data set, there's a few data which are few variables, I guess. So there's gender, and then this is to ensure that the respondent is game student, and then there's device used for gaming, game genre, graphic quality, game performance or game smoothness, game size, spending on games, time of day for gaming, time to clear game, time allocated for gaming daily, study time affecting game time or not, reason for gaming, and motivation from gaming. But for this project too, we only use a few of these data to and do some analysis on it. So we will do statistical inference analysis. So for this project, we will be doing 4 type of inference analysis, which are the first one is one sample hypothesis testing on spending on games. So for this one, we will be determining whether the mean of spending on game is 60. So this value of 60 is obtained from the sample mean actually. So it's an estimate for the population mean from the sample mean. So we want to determine whether the mean of spending on game of the population is equal to 60 or not. So that's for the first test analysis, which is on one sample hypothesis testing. And then the second one is correlation analysis. We'll be doing it on graphic quality and game size to examine whether there's a linear relationship between these two, which is graphic quality and game size. So for this one, we'll be calculating the coefficient of correlation between graphic quality and game size to determine whether the relationship is weak or strong or positive or negative. So that's for correlation analysis. And then next is the regression analysis on game size and time to clear game. This is we're doing the regression analysis to assess whether the game size can be the predictor for time to clear a game or not. So we'll be formulating the linear regression equation, which is b1 and y equals to b0 plus b1x. Right. So from that equation, we can test if whether there is linear relationship through the t-test, and from that we can see if there's a linear relationship between game size and time to clear game. And lastly, we will be conducting chi-square tests of independence on the gender and game genre to test whether there's to test the independence between gender and game genre. So from this, the outcome we will get whether to reject or not reject H0, where H0 is it shows that gender and game genre is independent, while alternative hypothesis is H1 is showing that there's dependence between gender and game genre. So that's for that. My teammates will be explaining in more in detail about these 4 tests.
My name is Wei Sheng. So first part I talk about the data analysis. For first part is one sample hypothesis test. So for the one sample hypothesis test, we are going to testing the mean spending of game. So before we start the one sample hypothesis test, we need to measure the mean variance and standard deviation. So we can see this is RDudio. We get the mean standard deviation variance. That is the sample size is N is 60, sample mean is 60.833, and sample variance is 3757.768, and the sample standard deviation is 61.301. So for the measure the center density of the sample for spending of gain above, it show the average is sample is the 60.83 on the gain, and with rust the variance and data deviation, we get the 3757.768, and we need the standard sample standard deviation is 61 and 0.301. So this is show the bending of gain is more disparate. So now we that the sample mean is the 60.833, we can now to take the population mean. If the sample mean is about the 60, let's assume the population mean is estimated to be the 60. So we can see the null hypothesis and alternative hypothesis. So now the hypothesis mean is spending of game equals to 60 ringgit, and alternative hypothesis mean of the spending of game is not equals to 60 ringgit. So now we have the null hypothesis and analytic hypothesis. We can calculate a test to test the whether given the null hypothesis we reject or fail to be the rejected. So this is the test statistics formula. So we need to T formula test statistics. So by the RStudio, by using the RStudio, we have test the statistics. T is the 0, 1, 0, 5, 3, 0, 0, 2. After obtain the T value, we have to calculate the critical value to the critical region of rejection. So critical value for the critical value for test, we will using the significant level of 0.055, which will give a 95% confidence level on the estimate mean. Since we are testing the whether mean is equal or not equal to 60. So this is not not equal or equal, so we will be conducting to two-tier test for the testing. Before to calculate to t value, we need to degree of freedom. So degree of freedom formula is sample size minus 1. So 60 minus 1, we get the 59. So we use the by using RStudio, we obtain the t critical value. For critical value is the 2.000995. So we need to plus and minus because in the conclusion, we can know to the negative 2.000991 and the positive to 2.00995. So with the testing test statistic, so we can get the 0.1053 002. So in the graph of the rejection region, we can see this is graph is the field to reject. So since if the testing is tested, T equals to 0.105 lies into the region is between the minus negative 2 and 2 and 2. So this show the with the field to reject to null hypothesis, though, and that is insufficient evidence that the mean spending of game is not to equals to 60 ringgit at the significant level to 0.05. Hence, we can conclude the mean of spending of game by the UTM student are above the 60 ringgit from the outcome of this one sample hypothesis testing. Yeah.
My name is Ong Ching, and now let us move on to the correlation test part of our report. In this part, we want to find out if there is a relationship between these two things, like how important student thinks game graphics are and the size of the games they play. So to achieve this, we use Spearman row rank correlation coefficient method, which help us to measure whether two variables tend to move together. So first, we look at the scatter plot, and visually it didn't show a strong pattern, which hint that there might be only a weak relationship between these two variables. So we calculate the correlation coefficient, and we got a value of negative 0.1478. And this negative number tells us two things. The first thing is there is a negative relationship, which means that as the importance of graphics go up, the game size tends to go down, but only slightly. The second thing is the number is close to zero, which means this relationship is very weak. To be more confident, we ran the hypothesis testing using a significance level of 0.05. As a result, our t-value is negative 1.138, and the p-value was 0.259, which is greater than the significance level 0.05. So based on this, we fail to reject the null hypothesis, meaning that there is not enough evidence to say that there is a real linear relationship exists. So in simple terms, this means that even though students might say graphics are important, that doesn't necessarily mean that they choose bigger size game. So in conclusion, this statistic shows that the relationship is weak and not statistically significant. Thank you.
My name is Dr. Kwan, and I'll explain about the regression test between the game size and also the time to clear the game. So before we're doing the regression test, we have to define that which one is the independent variable and which one is the dependent variable. So for the independent variable, it will be the game size, and the dependent variable will be the time to clear the game. So this test will be conducted to test whether the value of time to clear the game midpoint is depends on the value of the game size midpoint. So this scatter plot is sketched according to the sample data given between the game size and also the time required to clear the game. So this is the population linear regression and also the estimated regression model. So the estimated regression model is used to obtain the sample regression line to provide an estimate of the population regression line. So this model is so according to this model, we can see that the B naught is the estimate of the regression intercept. Also is the estimated average value of the time to clear a game when the value of the game size is 0. So besides that, we also have the B1, which is the estimate of the regression slope, and also called as the estimate change in the average value of time to clear a game as a result of a 1 unit change in the game size. So how do we get this B0 and the B1? So we will use the least square equation. So this equation we will apply it in the RStudio to find the value of B0 and B1. After we finish calculating, we will get the B1 as the 0.08508335, and the B0 will become 1.528902. So after we get those after we get this value, we'll substitute them into the estimated regression model equation. So the equation will be like this. So after we get this equation, we can identify something like the B naught is 1.5289. So about in this value, it is indicate that when the game size is 0 GB, which is gigabyte, the time to clear a game is about 1.529 hours. Although it is impossible for a game to have a game size of 0 gigabyte, but the value will automatically become 1.5289. So besides that, the B1 is 0.0851. It shows that the time to clear a game increased by 0.0851 on average for an increase in game size by 1 gigabyte. So after we had evaluate a simple regression model equation, so the equation may have explained and unexplained variation as the equation obtained is only an estimated to the population regression model. So we have to determine the explained and unexplained variation by calculating the SST, SSE, SSR, and also the coefficient and determination, which is the R squared. So first, let's talk about this formula first. So SST will it means that the total sum of squares. SSE it means that the sum of squares arrows, and the SSR will become the sum of squares regression. So this formula will be applied in the RStudio. So each variable contain each values. So after we calculate this SSE, SSR, and also the SST, so we also have to calculate the R square, which is the coefficient of determination. So the R square is actually the SSR divide the SST. So we also use it in the RStudio. So it will get the value like this, 0.12, something like that. So when we obtain the value like this, we can interpret that 12.1 percentage of the variation in the time to clear a game is explained by the variation in the game size. So besides this formula, we also have the standard error of estimate and also the standard deviation of the regression slope. So this above formula are also used in the RStudio to calculate some value. So with the evaluation of standard deviation of regression slope, we are able to make the inference on the regression slope by carrying out the hypothesis testing. So the hypothesis testing will be used the t-test. So after obtaining the simple regression line equation and estimate standard error of least square slope, which is the SB1. So we can make the inference on whether game size and time to clear a game has a linear relationship or not by conducting the t-value hypothesis testing. So first we will define the null hypothesis and also the alternative hypothesis. So the null hypothesis will such that the B1 is equal to 0, which is represent no linear relationship. And the alternative hypothesis, which is the H1, says that B1 is not equal to 0, which is says that it represents linear relationship does exist. So this is the the formula for the test statistic, and df is the degree of freedom to find the t-value. And so after we calculating the test statistic, so we may evaluate the critical value. So we have the significance level, with which the alpha is 0.05, and the degree of freedom we get is 23. And the t-test is a two-tailed test, so it will have two critical values, which is positive and negative 2.001717, and the t-value is calculated using this formula, and it will get as 2.824129. So after we get this from this value, we can draw a graph like this to show the explanation. So we can see that since the test statistic, which is the 2.824, is greater than the critical value, it's greater than the critical value, which is the absolute value 2.001717. So it shows that the test statistic lies in the rejection region. So the null hypothesis is rejected. So there is a sufficient evidence to show there is a linear relation between the game size and time to clear game at significance level of 0.05. And in addition, we also have calculated the p-value. So the p-value obtained is 0.06488, like that, which is less than the significance level of 0.05. So this comparison is also proof that we may reject the null hypothesis, and also conclude that there is a linear relationship between the game size and the time required to clear the game. So to visualize the linear regression relationship, so the simple linear regression equation is used to create a line that is added to our scatter plot graph. So the linear regression equation will be represented like this with a red line in the scatter plot. So this how we draw the linear regression for the relationship. So we can make a short conclusion. So in conclusion, the regression model indicates the statistically significant positive relationship between game size and the time required to clear a game. However, with an R-squared value of only 0.12009, the model explains a relatively small portion of the variation in clear time. So it suggests that the game size is only one of the several factors that affect the game completion time. So this is all about the regression test.
Hello everyone, today we explain a report that investigates whether there's a connection between game genres and gender using a statistical test called the chi-square test. I will walk you through everything clearly, covering all tables and figures, including the chi-square distribution graph. First, the dataset looks at how many males and females play different types of games. The genres include role-playing games, mobile, shooter, casual, simulation, and sport. The total number of players is 60. This is summarized in table 3.4.1, datasets of game genre against gender, which shows how many males and females participate in each genre. For example, 5 males and 12 females play role-playing games, totaling 17 players. For mobile, has 4 males and 8 females, and so on for the other genres. Next, we want to check if there's an association between game genre and gender. To do this, we compare our observed data with expected counts, assuming there is no relationship. This is shown in table 3.4.2. The expected frequency table, where expected counts are calculated based on the overall proportions. For example, the expected numbers of males in role-playing games is about 6.233, while female is about 10.77. Similar calculations are done for other genres like mobile, shooter, etc.
These expected values serve as the baseline to compare against our actual observed data. So using the observed and expected counts, we calculate the chi-square statistics, which is a number that measures how much the actual data deviates from what we expect if there is no relationship. This calculation results in a chi-square value of approximately 8.61, summarized in table 3.4.3, the chi-square test summary table. Before we interpreting this, we need to know the degree of freedom, which is calculated as rows minus 1 times columns minus 1 equals to 6, and the critical value from the chi-square table at DF equals to 6 and significance level equals to 0.05, which is 12.592. This explains figure 3.4.1, the chi-square table. Now onto figure 3.4.4, the chi-square distribution graph. This graph visualizes the chi-square distribution for 6 degrees of freedom. The graph shows the curve with the test statistics 8.61 mark on it. Since 8.61 is on the left side of the critical value line 12.592, it indicates our result is within the normal range under the hypothesis. This visual helps us understand that our test statistics fall in the range do not reject, or we fail to reject the null hypothesis. Comparing the test statistics 8.61 with the critical value of 12.592, since 8.61 is lesser than the 12.592, we fail to reject the null hypothesis. This means that there is not enough evidence to say that the game genres and gender are related in this dataset. So additionally, figure 3.4.3 presents the p-values about 0.1966, which is larger than the 0.05, reinforcing our conclusion. To summarize, we analyze whether game genre and gender are associated, and so the chi-square test show a value of 8.61, less than the critical value of 12.592, and the distribution graph in figure 3.4.4 illustrates where our test statistics lies on the chi-square curve. As a result, we conclude that there is no significant relationship between game genres and gender in this data.
So after my friend have explained on the four analysis, so now we will be concluding our test for our analysis for the project. So from the one sample hypothesis testing, we determine that we fail to reject H0. We show that the mean of the spending on games are estimated to be at 60, so at significant level of 0.05. So this shows that the spendings on game by a UTM student is average about 60 ringgit. So yeah, and after that, for correlation analysis, we had obtained the experiment correlation coefficient, which is equal to negative 0.148, which is closer to the absolute value is closer to 0. It shows that the relationship is weak, and then the negative sign shows that it's a negative relationship. So that means that when the graphic quality increase, the game size decrease apparently. So maybe this shows that the UTM student prefer game size that are small but still have a good graphic quality. So maybe so we can conclude that from our outcome here. And then for regression analysis, before that, for correlation analysis, we also got that there's no correlation between graphic quality and game size. So the t value we got is about negative 1.138,301, which lies not in the rejection region. Since it's not in the rejection zone, we fail to reject this now, and it shows that there is no linear correlation between graphic quality and game size. So that's all for correlation. And then for regression, we have obtained the simple regression linear equation, which is y equal 1.529 plus 0.085x, which means that hypothetically, if the game size is equal to 0 GB, which is impossible, but hypothetically, if the time to clear game is about 1.5 to 9, and then if the game size increased by 1 GB, it will add on by 0.085. After that, we also calculate the SSE, SSR, SST to get the coefficient of determination, which is 0.121, which shows that our equation can explain the change in game size by 12.1%. So only 12.1% is explained by the equation we got here, which is quite low, but at least it's something. And then we also have conducted a t-value test to determine whether there's a linear relationship, and we got the test statistic is 2.824. Meanwhile, the critical value of our test statistic is in the range of -2 to 2 at 0.05 significant level. So from here we can see that the test statistic lies in the critical region, and so that means that the H0 is related and there's a linear relationship in between game size and the time to clear game. So yeah, and then lastly, for the conclusion for chi-square test of independence, we have obtained the test statistic chi-square equal to 8.612. Meanwhile, the critical value of our at 0.05 significant level is about 12.592. So this means that our test statistic doesn't lie in the critical region. So we fail to reject H0, and that shows that the gender and game genre are not dependent or independent. So that means the game genre is not affected by the gender of the choice of game genre is not affected by the gender of the game student. So that's all for the conclusion.